Welcome to Study Loop.
This is the answer to Chapter 13, problem number 11 from the Smith Organic Chemistry textbook. And this problem gives us three sets of wavelengths. And so we're asked which of the following has the higher frequency for each of these pairs of wavelengths. And so the key to answering this problem, I've written across the top here, is that wavelength and frequency are inversely proportional. So a higher frequency is going to correspond to a lower wavelength, and a higher wavelength will correspond to a lower frequency. So for A, we're asked to compare light having a wavelength of 10 to the 2 nanometers and light with a wavelength of 10 to the 4 nanometers. So 10 to the 2 nanometers versus 10 to the 4 nanometers. And so 10 to the 2 is going to be the shorter wavelength. And as I said here, frequency and wavelength are inversely proportional. So a shorter wavelength is going to be a higher frequency. So higher frequency. Okay, and so for B, we're asked to make a similar comparison. So B is going to be light having a wavelength of 100 nanometers versus light with a wavelength of 100 micrometers. So here we're talking about 100 nanometers versus 100 micrometers. And so nanometers are going to be smaller than micrometers by a factor of 3. So by a factor of 1,000, really. And so the 100 nanometer wavelength is a smaller wavelength than the 100 micrometer wavelength. And so the 100 nanometer wavelength is going to have a higher frequency. Again, because frequency and wavelength are inversely proportional. So then for C, we're asked to compare red light and blue light. And so from looking at the electromagnetic spectrum, the visible light spectrum, which appears in the textbook, figure 13.8. So it's on the same page as this question, just a little higher above it. We're going to see that blue light is towards the left of the spectrum. Red light is all the way to the right of the spectrum. And so the lower wavelength is going to be toward the left. And so again, lower wavelength is going to correspond to higher frequency. And so the blue light here is going to have a lower wavelength and therefore a higher frequency than the red light. Okay, and so again, in order to solve this problem, we just need to remember that wavelength and frequency are inversely proportional, and then determine in each of these sets which is the smaller wavelength, and that will be the higher frequency. And that's the answer to Chapter 13, problem number 11.